Okay, next we have Ashley Jacobson from Minnesota DOT, and she'll be talking about recent innovations in concrete bridge decks.
All right, well, good morning. My name is Ashley Jacobson, and today I will be presenting on the NCHRP 2201 scan that was focused on recent leading innovation in the design and construction and materials used for concrete bridge decks. So this was a presentation that was originally presented by Dr. Pinar Akumis from the University of Buffalo, who was the subject matter for the scan. I unfortunately was not involved with this scan or workshop, and those from my state that were not able to attend, so they asked me to give this presentation on their behalf. So therefore, I will most likely not be able to answer any questions on this research specifically, but an email will be provided at the end, so if you do have any questions, you can contact them. So the motivation for the scan was to talk about three different things. So either materials, construction practices, or design practices to improve deck durability. So they did discuss other things like environmental sustainability and accelerated bridge construction for decks, but really the number one motivation for the scan was to focus on durability. So in case you're not familiar with the NCHRP scans, they bring together transportation agencies so that there is information exchange between the different agencies. So these are the following states that participated in the scan. Green ones are member states that were part of the scan team, and then orange ones are agencies that were identified with the scan team and invited to the workshop. So essentially it goes like this: they perform a literature review, figure out where the innovations are, and then invite agencies out for a week-long workshop. Then a report gets written based on that workshop, and so that is why we're here today, to discuss what will be coming out in that report. This is the contents of what will be included in the report. They discuss a variety of things that range from different concrete mixes, placement, construction practices, to fiber reinforced concrete, to corrosion resistance reinforcement, prefabrication, QA, QC, and design. The report should be available very, very soon, and there will be lots more information in the report, but the following will be just an overview of what was discussed and what was found out. So we'll start with concrete mixes, placement, and protection. The scan was focused on innovation, but this part is more about best practices and modern concrete mixes. Not too much innovation in terms of materials, but what works best for agencies that participated in the scan. So first thing that was discussed was what makes concrete mix crack less. So it was discovered that for those modern mixes that have less cracks, the paste content was limited. So if you limit that paste content, which would be our water and cement content, it does seem to result in fewer cracks, which does mean that it results in moderate strength, but the consensus was that we don't really need terribly high strength for concrete decks. Anyways, so there was some concerns though from some DOTs that you don't always get what you specify. So it's good to shoot a little higher just in case there is some material quality issues. So some states, because of that, still want to specify higher strength, but others are comfortable with a moderate strength, and then they did experience less cracking with that less cementitious material content. So here are three examples from the scan with their cementitious material content. The second thing discussed for concrete mix is that limiting concrete shrinkage strain seems to have a big impact. There's really a common performance requirement seen when agencies have these high performance mixes. So this can be achieved either with the mix or with shrinkage reducing admixtures. So California is a big fan of this, and they reported really great benefiting from adding shrinkage reducing admixtures without really seeing an increase in cost all that much. So from a few participating states, their shrinkage strain limit at 28 days is right around 300 and 350 microstrain. So how they achieve that, it's kind of up to them. So for example, Virginia DOT uses shrinkage reducing admixtures, but it's an optional thing. So if you can achieve that shrinkage strain without admixtures, then that's okay too. The scan also discussed placement and finishing. So it's not really innovation, but most DOTs agreed that you do get best quality concrete when you minimize finishing. So big thing is start external curing or wet curing right away. So they even discussed, bringing out work bridges to site so that workers can start curing right away, avoiding tining and instead saw grooving that hardened concrete so that you can start that external curing sooner. Some DOTs mentioned that monetary penalties per hour of delay in external curing just to encourage the contractors to start curing right away, and using missing if you can to help control evaporation of that concrete. So there was some discussion about specifying temperature changes for plastic concrete. So trying to pour when that ambient temperature fluctuations were small, or pouring when concrete and contact surface temperatures are small. So that would be the girders. So if the temperature of the concrete and the temperature of the girders were very different at that time of the pour, it seemed like it was causing more trouble. And so same reason, avoiding night pours. So really controlling that temperature as much as you can seemed to result in some better quality concrete. So for external curing, the key is to start right away, but there is this kind of new innovative way of curing concrete called internal curing. So essentially what it is you replace a fraction of your aggregate with a pre-wetted lightweight aggregate. The water in that aggregate is released over time to help hydration. So instead of just hydrating that surface of the concrete, you are essentially hydrating from inside out, so internally. They spent a lot of time on this during the workshop, and for some states like New York and Virginia, this is pretty much standard practice for them. They do this on all their concrete decks, and they have seen great results. But for other states, they have had some mixed results with this. So came to the conclusion that the states that have the good results must have some good quality lightweight aggregates. They are confident with the moisture content of the aggregates. Suppliers know how to store them. Versus if you have the mixed results, you either probably don't have lightweight aggregate at all, or you're not sure about the quality of the aggregate, or the contractors are inexperienced with it. So this is a method that does require a good amount of owner involvement just to get it set up right. So if there is some insufficient owner oversight to get this method working, that's kind of when the mixed results come in. So that's really all there was to talk about when it came to concrete mixes. The next thing that was discussed was adding fibers to concrete. So some agencies do this to have an additional measure to protect against any issues with quality of that materials they get, or that construction quality. So construction quality is important to make concrete crack less. So to protect against that unexpected or undesired events, it may be good to add fibers into your concrete. In California and Minnesota, this is standard practice for them to have fibers in their deck mixes. But one thing that is important to emphasize is that if you just add fibers into your mix and think that it's going to work, that's probably too naive of an approach. The types of fibers, the various different suppliers, the size of fibers, orientation, distribution, those all have a great impact on the results. And of course, just adding fibers also changes the workability of the mix. So just like any innovation, doing some iterations and improving that mix over time is what's needed here. So one recommendation that is going to go into this, or that came out of the scan, is we do need some testing methods and acceptance criteria to be able to approve different fibers and suppliers. So I know that Minnesota has an approved list of suppliers for these fibers, but not everybody does. So some national acceptance criteria and tests are needed. The next thing was ultra-high performance concrete, so UHPC. You've probably all heard of this as it's such a popular topic right now. It is a type of fiber reinforced concrete, with the fibers typically being high-strength steel fibers. UHPC usually has a certain performance objective, and that performance objective is that it's very high compressive strength, so something like 22 KSI is possible, which again is not very critical for decks to achieve, but it is it's got that very high packing density and low permeability, so that does make it very durable and does make it attractive for deck applications. So a few applications were discussed, one example being link slabs, or rather that piece of deck that goes over the supports or connects to girder ends. So link slabs were used with conventional concrete as well, but that they tended to be much wider with conventional concrete. So New York has started replacing some bridge decks expansion joints with these link slabs, and they have reported to have great results with these. So when you switch to UHPC, they can now actually have a link slab that is much shorter, so just a couple of feet wide instead, and that thickness is also thinner. So this completely eliminates that expansion joint and gets a much more durable deck. The second example of UHPC application is in deck panel joints between precast concrete deck panels. So UHPC, as you know, is a much more expensive, it's much more expensive than conventional concrete. So most of the applications you see will be on a small volume application. So you can use UHPC for precast concrete panels, either between the panels or between the panel and the girders. Some really key points for making UHPC work, and this is not just for these two applications discussed, but for really any application of UHPC. One very important thing is to really seal the forms against leakage, because UHPC is a lot more flowable than normal concrete. So that is why you see on that right side there is actually a top cover as well for the form. And its material tends to settle a little bit when it hardens, so you actually have to fill the joints a little bit more than you need to account for that settlement. So that's why you see that bucket here. It's maintaining that hydraulic pressure over that joint, and if you have a little bit extra, then you can just grind it off later. The other thing is that you are pouring if you're pouring UHPC at point A and you expect it to go to point B, and those 2 points are very far from each other, and UHPC is going to flow a very far distance, then what can happen, and what has been reported of happening, is that the fibers all orient in that same direction of the flow, which is very undesirable, as we want really a random distribution of those fibers. So keeping that flow length short is recommended. And then just like any application with connections, roughening that concrete surface is very important to bring those panel joints or whatever joint it is to a saturated, dry condition before placing UHPC. That really makes a difference. So some DOTs reported that they require the supplier of UHPC to be on site to help with these things. If it is a proprietary product, one reason why that material is so expensive is that it comes with support. So, especially if the contractor is not all that experienced, it may be a good idea to have that requirement in your contract. And then finally for UHPC, as I just mentioned, the proprietary mixes can be very costly, although now there are multiple vendors and suppliers of UHPC, and that cost is expected to go down. Many states or universities are now developing their own non-proprietary mixes. So we kind of there's 3 examples here for Iowa, Michigan, and Texas, because they participated in the workshop in the scan. But really there are many others across the country that are being developed. All right, so next up is corrosion-resistant reinforcement. We just discussed that you can control cracking with the concrete mix itself. So if you can come out with a modern mix with low shrinkage, low paste content, high construction quality mix, then that's really the best option, and that is what should be prioritized first. And then corrosion-resistant reinforcement should really come next, and discuss, taking a service life approach to that higher initial cost for that usage. So, do we need 100 years of service life? Do we need 100 years of deck service life, or can we just replace a deck? So that maybe then corrosion-resistant reinforcement might not be needed for that deck. So starting with FRP rebar, so fiber reinforced polymer or fiber reinforced plastic rebar, there are different kinds of FRP rebar. So there's glass, carbon, and aramid. But glass tends to be the most common because it's cheaper. So most of this discussion focused on glass FRP rebar. We heard a lot from the Florida DOT, as they have used FRP rebar since the 80s, and they have a great website dedicated to their FRP research. Although most of their use is for substructure units, and that's because in Florida, Their corrosion comes from the salt water and not the de-icing salts. So the differences between FRP rebar and metallic reinforcement is that it doesn't corrode because it's not metallic, and it is very lightweight, so it's very easy for the construction workers to pick up rebar and move them. So then you can technically get a smaller reinforcement cover because it doesn't corrode, so you don't need that large cover. But there was some discussion about how the FRP grid may float during the concrete pours if you don't secure it well in place. And so because of that, some DOTs were worried about that floating issue, and they still went with the larger cover. So these bars do not yield, so essentially they're elastic and then they fracture. So because glass FRP is not as stiff as our steel bars, crack control usually does control the design. The other thing to be wary of is that these glass FRP bars can get damaged easily during demolition or concrete removal, kind of making it pretty much impossible to widen a deck. So some workarounds for that, some agencies reported steel metallic rebar on the edges of the bridge, so to facilitate future widenings. So using FRP and metallic together so that they could widen that bridge later on. FRP bars cannot be field bent, so that's just, they do come pre-bent, so just something to keep in mind. Most FRP products are proprietary, which has an advantage to it, so that means that the companies are constantly improving their products. So the FRP rebars you used 10 to 15 years ago are not the same FRP rebar that we have today. So the recommendation from the scan was to invest some funds to research these newer and hopefully better products for both short-term and long-term performance. There was some discussion about stainless steel rebar, and when it came to that, the conclusion was, it's an alloy, so not all stainless steel is the same. So the performance will depend on the type of stainless steel rebar. We learned from Virginia DOT that they have these X-ray fluorescence handheld devices that can tell you the composition of the alloy, that they were using it to verify that what you specified is what you actually received from the manufacturer. So this is a quick way just to check that the alloy and verify that it meets your specification. So Virginia and Michigan DOT reported the cost of stainless steel. Virginia reported about a 5% additional total cost if they use stainless steel in their deck, and their justification is that that cost may be smaller than a future overlay. And then Michigan DOT reported about a $17 per square foot increase in cost back in 2011. And then we have the ASTM A1035 bars, which you may know them by their brand names, MMFX or Chromex. So these are chromium alloy bars, and we have three different types, CS, CM, and CL, with CS provides the highest corrosion resistance, and so of course that comes with the highest price. They come in either 100 KSI or 120 KSI yield strength. And most agencies that participated in the scan reported that they chose not to rely on that high strength, so that they just use it as a one-to-one replacement of our good old 60 steel, grade 60 steel, or you can just cap the yield strength in the design to be conservative. There isn't all that much data for the long-term performance of these bars, so most states use the CS type because that is supposed to provide the most corrosion resistance. The cost is a little bit higher. Michigan DOT numbers reported from 2021 are $2 to $3 a pound versus the $1 to $2 a pound for epoxy coated bars. All right, so next up is prefabrication of decks, and so due to time, I really won't go into much here, but the report will address all of these items. So just picked one to go through today, and that is a partial depth precast deck panels. So these are essentially like stay-in-place forms and are about half the deck thickness. So we heard quite a bit from Texas DOT because apparently 90% of their bridge decks are built this way. So standard practice is to use stay-in-place or partial depth precast deck panels for their deck construction. So other states in the scan, they've used this, but not everybody has had a great experience with this and reported reflective cracking when they use deck panels. when they use these panels. But Texas told us about two important things regarding their key to success. So the first being that they have these bedding strips, so these like black rectangles. They have these bedding strips that are of a particular size, and the reason why it's there is because they want to make sure that the cast-in-place concrete gets under that precast deck panel and that it's well consolidated underneath that deck panel, and it becomes a good permanent support for that deck panel. And then the second key point, just like you heard me mention for UHPC, really bring those panels to that saturated surface dry condition by pre-wetting them, and then you get that great bond between the two. All right, so coming towards an end, next we'll discuss how design and detailing practices may improve our deck performance. There's quite a bit of variation in design and detailing practices among states. Even within a state, these design and detailing practices, vary over time. So something very important to note here is that because of that, because these things change over time and from state to state, it's really critical to document the implication of these changes. So keep track of your innovation. If you're changing something in design, was it successful? Did it do a good job, both short term, but also hopefully long term? Texas DOT talked about how they reduce the amount of reinforcement that they have in the decks as a method of reducing cracking. And that may sound kind of counterintuitive, but their reasoning is that if you have smaller reinforcing amount and the corrosion product that builds over time will be small, and that will create less pressure when they expand and result in less cracking. The other change that they made is that at the very top layer of rebar, the layer closest to that top surface is the longitudinal rebar. And the reason for that is because their prevalent cracking was in the transverse direction. So the longitudinal rebars restrained those cracks better. They did help reduce overall cracking. So they got much smaller transverse cracking, but more longitudinal cracking. But overall, they did see a reduction in cracking, and they're happy with these changes. And then the last part, quickly, we talked about quality control, quality assurance, and different practices for making sure that that workplace knowledge is there and it continues to be there. So in terms of construction quality practices, I think that everybody can agree that, especially if you're using an innovative product, something new, that you have to be really well prepared for it. So, for example, Washington uses these test pours for a new mix. So it could be on-site or off-site, but if the contractor does a test pour, then they know what to expect with that workability of that mix. Encouraging pre-deck pour meetings and construction checklists. And of course, training people. Talked quite a bit about that during the workshop. Some DOTs provided training programs both for internal and external staff inspectors and have certification programs as well. And then also frequent sampling of your certified inspectors. If you're using alternative bars, frequently sampling of that is important. There has been some quality issues with rebar, especially the ones that are alloys and not pure materials, so making sure that you're testing those alternative rebars. In terms of knowledge continuity, what do you do when people have that knowledge now, but when workforce changes, with people retiring, how do you make sure that knowledge stays in the agency? So one thing we know is that, innovation doesn't just happen over time. It does require iteration. So if there's a champion of that innovation in the agency and they disappear, then that innovation shouldn't just stop there. So keep good track of these innovation projects. How are they doing now? But also how are they doing over long term, and as that impacts the decision in the future. So Utah, they've created an innovation-specific database or inventory for their bridges. Florida's maintained that great website with research information, research reports, demonstration projects. So all these things help keep track of these innovations and how they're performing. So just to wrap it up, these are the 10 recommendations from the scan. So documenting innovation, training certification, being prepared, investing in research for life cycle deterioration models, developing modern mixes. So again, that report should be available very soon and will provide much more detail into that scan recommendation. So this was the SCAN team, and here is the email listed for Dr. Pinar Okumis if you have questions based on what you heard today. So thank you very much for your time, and I hope that it was helpful.